Hello students, in this video we do chapter 2 numerical applications from the student support material uploaded by Cbse. Exercise 1D, question number 4. A cone is surmounted on a hemisphere as shown here. The radius of the solid formed is 6 cm and its height is 21 cm. The radius of the solid formed is 6 cm. So that means this radius is 6 cm and the height, it is not the height of the cone, it is the height of the solid formed. So remember that, read the question properly. It is not the height of the cone, it is the height of the full solid. It is the height of this solid formed. This 21 is the height of this full solid. So this is 21. Therefore the height of the cone will be, this is 21, the radius is 6. The radius is given as 6. So 21 minus 6, that is, this is equal to 15. So the height of the cone is 15. So the height of the cone is 21 minus 6, it is 15. Now the radius is 6. The radius of the solid formed is 6. Now we have to find the curved surface area of the solid. Curved surface area of the solid is curved surface area of the cone plus the curved surface area of the hemisphere. So what is the curved surface area of a cone? It is pi r L. L is the slant height plus CSA of a hemisphere is 2 pi r square. So we can take out the common term. Pi is common, r is common. So you get L plus 2r. You have taken out pi and r. Pi you can substitute 22 by 7 or 3.14. Radius is 6. Now slant height we have to find. How do you find the slant height of the cone? The height of the cone is 15. This is 15. And the radius is 6. So the slant height is, this is a slant height. Suppose if I name this as ABC. AC is the slant height. So use the Pythagoras theorem. It is 15 square plus 6 square. So 225 plus 36. Square root of 225 plus 36. That is equal to root of 261. So root of 261 is approximately 16.16. You're getting 16.155. So approximately you can write it as 16.16. It's the slant height of the cone. So pi r, the CSA of the solid is pi r, L plus 2r, pi 22 by 7, r is 6, L is 16.16 plus 2r. 2r is 2 into 6, that is 12. We get 3717.12 by 7. So we are getting approximately 531 centimeters square. So the curved surface area of the solid 531 centimeters square. Now next is you have to find the volume of this solid. So the volume of the solid is volume of the cone plus volume of the hemisphere. Volume of the cone is 1 by 3 pi r square h. Volume of the hemisphere is 2 by 3 pi r cube. So you can take out the common term. 1 by 3 is common, pi is common, r square is also common. So we get h plus 2 is there. Pi by 3 r square we have taken out. So you have only r here. Pi by 3 r square you have taken out. So you have only r. So 1 by 3 pi is 22 by 7. R square, r is 6. So r square is 36. H is the height of the cone, that is 15 plus 2 into r, that is 12. So when you calculate this, you get 22 by 7, 36 into 9. That is 7128 by 7, 1118.28 centimeter cube. It's the volume, so it is centimeter cube. 1018.28 centimeter cube. Question number 5. Find the area of the greatest circle which can be inscribed in a square whose perimeter is 180 centimeter. This is a square and this is the greatest circle, the maximum circle which can be inscribed in a square. The maximum circle which can be inscribed in a square you have to find the area of that circle. So this is a square. Its perimeter is 180 centimeter. What is given here? Perimeter of a square is given as 180 centimeter. You know the perimeter of a square is 4a. Suppose you take the side as this side, take it as a. So this is 4a. So a is equal to 180 by 4, that is 45 centimeter. So this is the side of the square a. A is 45. So this means this diameter is 45. This is a diameter. The diameter is 45. So when the diameter is 45, what is the radius? The radius will be, the radius of the circle will be 45 by 2. So A is 45. A becomes the diameter. A is the diameter. Side of the square becomes the diameter of the circle. So diameter of the circle is 45. So radius is 45 by 2. So remember, the side of the square becomes the diameter of the circle. Diameter of the circle is equal to side of the square. Area now. Area of the circle is pi r square. So pi 22 by 7. R is 45 by 2 into 45 by 2. So we can substitute pi as 3.14 also. So we get 22,275 by 14. So it's approximately 1591.07 centimeters square. So the area is this 1591.07 centimeters square. Question number 6. The length and breadth of a rectangle are increased by 30% and decreased by 20% respectively. This is the length and this is the breadth. The length and breadth of rectangle. So this is the length and breadth of the original rectangle. Here, the next is you are getting a new rectangle. The length is increased by 30% and the breadth is decreased by 20%. So the length is, original length is this L. So L plus the new length is 30% is increased. So the new length is L plus 30 by 100 of L. And the breadth is decreased by 20%. That means a new breadth will be breadth minus, it is decreased. The original breadth is B minus 20 by 100 into B. This is the new breadth. So the new length is L plus 30 by 100 of L. That is L plus 30 by 100 is 0.3 L. So we can take out L outside. So it is 1 plus 0.3. So the new length is 1.3 L. New breadth is decreased by 20% of the original breadth. So breadth is B minus 20 by 100 into B. That is a new breadth. So B minus 20 by 100 is nothing but 2 by 10. That is 0.2. So take out B outside. 1 minus 0.2. That is 0.8 B. This is the original breadth and this is the original length. So what is the new area? The new area is length into breadth. The new length is 1.3 into L. The new breadth is 0.8 into B. So 1.3 into 0.8 is 1.04 L into B. Question here is find the percentage of increase. So what is the percentage of increase? The percentage increases increase in area. The area is actually increased. The original area is L into B. The new area is 1.04 into LB. That means the area is increased. So the increase in area, the original area is L into B. The new area is 1.04 into LB. That means the area is increased. So what is the increase in area? The new area minus the original area. So that means 1.04 minus 1. That means it is 0.04. 1.04 LB minus LB. That is 1.04 minus 1 into LB. That is 0.04. So what is the percentage increase? The percentage increase is increase in area divided by the original area into 100. The increase in area by the original area into 100. What is the increase in area? 0.04. The increase in area is 0.04 LB by the original area is L into B. So 0.04 LB by LB into 100. That is LB and LB cancel. 0.04 into 100 is 4%. So the increase in area is 4%. The percentage of increase is 4%. Question number 7. The dimensions of a cuboidal hall are 10 meter, 12 meter and 15 meters. Find the length of the longest rod that can be fitted into the hall. So the longest rod is from this extreme, this vertex to this extreme, opposite vertex. So that means BH is the longest rod. Now from this corner to this corner, longest rod that can be fitted, that means BH we have to find. To find BH, let us find first BG. Let us find BG. So BG is, you can use the Pythagoras theorem. This is 90. It's a cuboid. So this angle is 90. So what is BG? BG is root of L square plus B square. Now we have to find BH. So BH is, again use the Pythagoras theorem. So BH square is, what is BH square? BG square plus GH square. So BG square is nothing but L square plus B square. BG square plus GH is H. So BH is root of L square plus B square plus H square. So that is a formula to find the length of the longest rod. Root of L square plus B square plus H square. So root of length, breadth and height are given 10, 12 and 15. So 10 square plus 12 square plus 15 square. That is 100 plus 144 plus 225. That is 469. So root of 469 is approximately 21.65. So the length of the longest rod is 21.65 centimeter.